Hi and welcome to the demo about monitoring and alerting. So here I will show you two different phases, I would say, hardware phase and business phase for monitoring, and complete the picture with an example of alert. So as usual, it will be a Docker-based demo where I will use different services. I will use Grafana for dashboarding and alerting, Prometheus as my time series database, later an Kafka extension to collect all metrics that are available on Kafka, and also Elasticsearch that I will use for the business related alerts and monitoring, and MileDev, which is a kind of simulator for SMTP server. So all started, and I will create my topics. And I will also open the Grafana dashboard. I will not change the password. So we can already see that we have two dashboards for the hardware metrics. And in these hardware metrics, you can see things that are not necessarily related to the business applications we have, but mainly to the infrastructure we are using to run our Kafka topic, Kafka broker in our case. So here we have the information like the memory usage, CPU usage, free memory, and different other things like file descriptors and available virtual memory. We also have the information about the topics, the throughput, and we can also later check them more generally by selecting various topics. So that's for the hardware version. And how does it work under the hood? Under the hood, the solution connects to the Prometheus scrapper, so server, that exposes some metrics that are later returned and printed in this dashboard. So maybe I can show you one. If I try to edit this, you can see that we issue a request to Prometheus, and we want to get this metric. So, and it will be maybe even clearer right now. It's the Prometheus interface with the query, I would say, with the query engine here. And how Prometheus knows about all these metrics. So it doesn't connect directly to Kafka JVM because it is too dangerous from the security standpoint. Instead, it relies on the metrics that are exposed from the JMX. JMX stands for Java Management Extension. It provides tools for monitoring JVM-based applications. And since Apache Kafka is a JVM-based application, well, we can use it to fetch different metrics and expose them to Prometheus, and as a result, expose them also to our Grafana monitoring. And that's for the, I would say, hardware or infrastructure monitoring, which is also important because you can imagine that if suddenly the memory usage spikes, it's nothing good because maybe you are ingesting too much data and your cluster is not sized correctly, and obviously it will crash sooner or later. But that's the first part, and this part alone is not enough. We should always complete it with some business related information. And for this business related information, I created a dedicated demo. So because it talks about business metrics, so obviously some code that processes data with some business rules. And I start here the demo with this data generator part. So as I said in the introduction, I'm using here Elasticsearch to store this business use metric because it's much easier to integrate for the demo. And I will create the index for validation for the use. So in the demo, I would, as my business metric, I would like to track the number of valid and invalid users passing in my users topic. So remember, we have here three topics for users and valid and invalid users, where we are going to push dispatch data. So in the data generator, I'm starting by creating the index, and later I'm generating different users that are either valid or either active or inactive, and that sometimes are invalid because they don't have the ID. And I'm inserting it to the user's topic. Correct. Okay. And for the data reader, so data reader starts very simply. It reads data from the topic, processes always 10 records, and build a structure. And the more interesting part happens in the for each batch method, where I'm defining two accumulators. So accumulators are kind of data collectors, local data collectors that are sent to each executor, and later when you call the count method, Spark will collect all partial values on these executors to the driver and give you the information, the whole information. So here I have two executors, the invalid for the invalid users and for valid users. And as you can see in my mapping function, I verify whether the login, so it was login not ID, my mistake, whether the login is empty or not. If the login is empty, it's an invalid user. If the login is not empty, it's a valid user. And typically here we also return the different topic, and so that we can dispatch data later. So after dispatching the data, I'm calling Elasticsearch to index above accumulators. Accumulators for valid users and for invalid users. It's quite important to define the timestamp that I will use to plot and to alert on the values. So I have the validation outcome and the number of valid or invalid users in this micro batch. So I will start the data generator. Yes, and after creating the first users, I will run my data reader. You can already see that we have some stats. So now I can go to the data sources. I'm not sure if this data source is correctly configured. Yes, it was a higher index. And yes, apparently it's okay. So I will now try to create a dashboard. And in the dashboard, I will use the validated users index. That's fine. And in the first plot, I will plot the valid users. I will copy it and plot invalid users this time, so that we should see two different. Okay, I have the aliases, and I will also define the same time interval. And I will also define a different transformation where I will sum the number of values occurred in the last minute. And you can already see that we have different information for the number of valid and invalid users, and so that we can track the data that we are processing. And here, when you take a look in our infrastructure monitoring with invalid and valid users, you can already see that we have some data. We have different log size. We have some throughput information. So it completes a bit the business data we have here with some technical information that will be also useful for debugging, for understanding what's going on. So I will save it as valid invalid users count. And that's nice. We have the alert, we know what's going on, but it's not enough because remember the dashboard fatigue, the refresh fatigue. When you don't have any automated alert on the unexpected things, you will be, you will of course need to go to the dashboard, refresh the page, analyze the result with your mind, say whether it's okay or not. And to mitigate that issue, I will try to send an alert that should arrive to my fake SMTP server. So I will now create a new folder for alerts, and I will create a new alert rule for too many invalid users. It will be a Grafana managed alert that I will save in the alerts directory. For the alert definition, I will use the same, I would say, mode as for the dashboard. So I define the query when I want to filter only the invalid users with 1 minute interval, and I'm only taking into account uh, uh, the results with at least one document indexed. Later on, I will trigger, I define the trigger condition, so I will trigger the alert if there is now at least one such invalid user. Later, I define the evaluation period, so it will be every 10 seconds for 1 minute just to get the results faster. I can also preview the alerts if needed, and I define the content with a custom tag that, for example, you could use to maybe apply different treatment, different interpretation for critical or warning errors. So I save the alert. So you can see that it already triggered a few minutes ago. So now it passes to pending state. And normally, yes. So that's the information that my previous alert succeeded. So it was resolved. And now you can see that it detected more than 0 users that are invalid and notified me. So triggered the alert. So it's in the firing state, meaning that there is something wrong that happened. And we have our information about too many invalid users for the reader. And with all the labels, I added this critical one. So you can already see in this part of the demo that we have not only the mechanism, which is quite similar to the mechanism used to define the dashboards, by the way. We don't only have the mechanism for firing the alert, so for detecting the alert, but Grafana also provides a mechanism of state management. So generally, if there is the alert that the condition that previously was in alert state evaluated to a normal state again, so Grafana sends an automatic notification to the channels we defined so that we can only be aware of when the alerts ended. So maybe if meantime we missed the alert and it resolved by itself, we will not need to make any human action. And it greatly completes the firing method. So you saw in this demo that, so you saw in this part that alerts are defined similar way than the dashboard as the dashboards, and that also it provides two views. So the alert view when we have this firing message, and also the resolution view. So when the alert terminates, either by itself or by your human intervention. So it's good to know because it can avoid you looking and debugging the alert that is no more relevant. To sum up, in this demo we saw first the dashboarding, so the hardware infrastructure-based dashboards that are mostly provided by the data source, data store, and the business related dashboard that requires writing some custom code and setting up different mechanism like we have done with the Spark accumulators. And additionally, on top of that, we added a business rule alert, but of course you could also apply this alert for the infrastructure dashboard to be aware and to be alert when something bad happens. Thanks for watching and see you in the next lesson.